in a random sample of 104 light bulbs, the mean life, or the average life, how long they last, is 543 hours. And let's assume all such light bulbs out there have a standard deviation of their life of 26 hours. Let's construct a 90% confidence interval estimate for the mean life of all such light bulbs. Okay, so just in terms of the color coding over here, yellow, those are the values given in the problem. So let's start there. We're given that the level of confidence is 90%. So let's say 0.90. The mean of our sample is 543. The population standard deviation is 26. And the sample size is the 104 light bulbs, so N is 104. Okay. So we're constructing a 90% confidence interval estimate, so we need critical values associated with a 90% confidence level. And so if we look at the normal distribution as our model, we have 90% of the area is in the middle, and we have 5% on the right, 5% on the left. Now you could loosely think about those as being the chances of being wrong. And if you're wrong in making an estimate, you could overestimate. And we're saying, all right, there's a 5% chance of that, and you could underestimate. There's a 5% chance of that. So we need this z-score. That's the critical value. That's the critical value. All right, so this z-score separates the top 5% of area from the bottom 95%. So everything to the left, remember Excel only works with area to the left. So everything to the left adds up to 0.95. You have the 90% in the middle and the 5% on the left tail. All right, so to determine the critical value, we'll use the norm.s.inv function, the inverse of the standard normal distribution function. This function gives us a z-score if we know area to the left of that z-score. And probability means area, so Excel is asking for the probability, which would be 0.95. All right, so there's our critical value. Now, we have to, sorry, that's in the wrong place. Now we have to use this critical value to construct our margin of error, and then our margin of error will give us our confidence interval. So norm.s.inv. Okay. So our formula for margin of error, E, is equal to the critical value, Z alpha over 2, times the standard error of the mean, which if we know the population standard deviation, it's the sigma divided by the square root of n. All right, so let's use Excel to calculate that. So the margin of error should equal the critical value, which we have right here, times the population standard deviation, and that's divided by the square root of n, so SQRT for square root of the 104. All right, so that means our confidence interval estimate will be our point estimate, 543, plus or minus our margin of error. So our confidence interval estimate is that the population mean is somewhere between the sample mean minus the margin of error and the sample mean plus the margin of error. All right, so for CI lower bound or confidence interval lower bound, that should equal the point estimate, the 543, minus the margin of error, and our confidence interval upper bound should equal our point estimate plus the margin of error. And we could round these to 1 decimal place because our original data is rounded to no decimal places. So let's just do that. All right, so that's it. Our confidence interval estimate is that the population mean for this particular sample is between 538.8 and 547.2, and this estimation is based on a 90% level of confidence. All right, that does it for this problem. I hope it was helpful.